You are listening to the Information Security Notes and Podcast, Episode 6, originally released on May 8th, 2020. My name is Josh Amishav. This week we'll talk about how to find open NoSQL databases like Elasticsearch or MongoDB. I think it's safe to say that there are at least one major leak every week, but usually more, due to open Elasticsearch databases. They're often a goldmine of information, and as I like to say, you can only protect what you can enumerate. So we'll talk about a couple of techniques you can use to track down open NoSQL servers. But first, this week's InfoSec news. Direct support for this podcast comes from BreachSense, the data breach monitoring platform. In honor of World Password Day yesterday, Balbix released a report highlighting their research into password usage. According to the report, 99% of users reuse passwords across work accounts or between work and personal accounts. While this isn't really news to anyone, it really highlights the risk to the enterprise. Credential stuffing using stolen passwords is one of the most common ways systems get breached. Credential stuffing is when a malicious user brute forces the login functionality by automating requests to try different username and password combinations to get into other people's accounts. Without visibility into the latest data leaks, businesses can't protect against this attack. Barring 2FA, if an attacker has valid user stolen credentials, they're going to get in. BreachSense helps solve this by alerting you when your employees' or users' credentials are leaked. Integrate BreachSense's powerful yet easy-to-use API into existing security solutions to prevent account takeover and stop online fraud. Researchers from InfoSec released a tool to test how various platforms handle cross-site scripting injected into polymorphic images. The issue is that there are three popular libraries for image processing: ImageMagick, GraphicsMagick, and LibVips. Normally, when a user uploads an image, the application does various things to that image, like strips metadata and reprocesses the picture, perhaps to a different format, like converting a PNG image to a JPEG. The researchers found some interesting tricks that can be used to hide web shells or JavaScript payloads within the image that can survive this processing. And the kicker is that when the content is hosted on the same origin or domain, like in the case of Google Scholar, this completely bypasses the self-CSP directive. CSP are headers that web applications can add, which define where JavaScript can run from and are used to help prevent cross-site scripting attacks. InfoSec made the images embedding the on-click and on-mouse over events public so anyone can use them for testing. They also released the Image Library Testing Suite on GitHub, and I'll leave a link to that in the show notes. Researchers at F-Secure found a major vulnerability in Salt this week. Salt is a popular DevOps configuration tool to manage servers in both data centers and cloud environments. It's sort of like Puppet if you're familiar with that. So the vulnerability was that attackers can bypass the authentication and execute code with root privileges on both the master and minion servers. Based on a quick showdown search, there are over 7,600 Salt masters openly discoverable on the internet. In fact, one of DigiCert's certificate transparency log servers was compromised via this vulnerability. Funnily enough, the attackers apparently didn't realize what they had access to and wasted having root access on a CT server to mine cryptocurrency. Lineage OS, a alternative mobile operating system, as well as the Ghost blogging platform were compromised as well. Now, to protect against this, Salt users should make sure that all patches are applied and that they only expose their Salt master to trusted Salt minions. In other news, Bellingcat has a fascinating article on how they use various bits of open source intelligence to track down Dmitry Badin, the hacker indicted by Germany for attacking the Bundestag. Dmitry is assumed to be a member of Russia's GRU hacking unit, better known as APT-28, which is known for its involvement in the DNC hack as well during the previous US presidential elections. In 2015, various members of the German parliament received phishing emails that contained malicious code that stole passwords and spread itself across the network. After a couple weeks, the malware had completely taken over the Bundestag's IT infrastructure, which stopped access to its online services and external website. In the background, the hackers exfiltrated over 16 gigabytes of data, including mailboxes of German members of parliament, and even Angela Merkel's office was breached. Now I want to talk about the process Bellingcat used, specifically the tools that they used to track Dmitry down. Dmitry is on the FBI's wanted list, and as part of that, the FBI published his passport picture. Bellingcat searched that image on the Russian social media reverse image search application called FindClone. Using that, they found Dmitry's photographs in his wife's VK account. They then revalidated that it's the same person by comparing the two photos in Microsoft Azure's face verification tool. Next, they used a leaked Moscow car registration database to get his full name and birth date. The car registration included the owner's passport number and place of issue, in this case St. Petersburg, as well as his registered address. The registered address, based on publicly available Russian corporate registries, belongs to GRU's military unit 26165. This unit is also known as GRU's 85th Main Center, specializing in cryptography. This is an interesting OPSEC move by the Russians. Previously, Bellingcat found 305 other GRU officers whose cars were registered to the same address. They then used another leaked parking database to look up his license plate number and found that he frequently parked his car near the dormitory of a Russian military academy. The parking logs contained two phone numbers he used for mobile payments. Those numbers were in two different phone number lookup apps under his real name as well as an alias. One of the aliases was Scaramouche, which was also found in various APT28 tools, tying him back. This blog post is a great tutorial on how to leverage publicly available data to research a target. ZDNet has an article analyzing the number of times the word ransomware is mentioned in SEC filings. In 2014, there were only 3. The following year, that increased to 8, and then that jumps to 45. And then in 2017, to 258. In 2018 and 2019, that number more than doubled and was at 1,139. And now in 2020, and we're in the beginning of May, not even halfway through, the number is already 743. This is an interesting technique to gauge how serious a threat is. And on that topic, Cyberscoop reported that Taiwan's state-owned energy company just had a ransomware attack that stopped users from being able to buy gas. And we're on that topic of attacking state-owned infrastructure. Fox News reported that attacks on the Israeli water treatment plants we talked about last week were carried out by Iran using US servers. Now, while the attribution is interesting, I'm more curious how 2FA isn't required to access these types of systems. The US Department of Homeland Security announced that they plan on running their own DOH or DNS over HTTPS and .DNS over TLS servers for official government use. But until then, they want all agencies to disable DOH and DOT support on employees' browsers. The claim is that the government-sanctioned DNS servers come with syncalling capabilities, meaning they can override the DNS settings for IP addresses that are known to be malicious. Homeland Security said that it doesn't endorse using third-party DNS over HTTPS servers like Google or Cloudflare. Both DNS over HTTPS and DNS over TLS encrypt queries to prevent third-party DNS servers from observing what domains was queried. DOH is enabled by default in Firefox for US-based users. Chrome is experimenting with this as well, so it definitely looks like this will be the way forward for DNS. For Firefox users outside the US, there are a couple ways you can enable DOH. One way is by typing about :preferences in the search bar, then scroll down to Network Settings, then click on Settings, then click on Enable DNS over HTTPS. You can then choose to use the default Cloudflare DOH server or supply a custom server of your choosing. In other news, Zoom bought Keybase this week in an attempt to improve their security stance. Keybase is a secure end-to-end messaging and file sharing service. This means that, as opposed to previous times, Zoom can actually claim to support end-to-end encryption in certain circumstances. This is important to note. As opposed to tools like Signal, Wire, and WhatsApp, only Zoom's paid accounts can use the end-to-end encryption. And when the end-to-end feature is enabled, which sounds like it won't be the default, the cloud-based recordings and joining by phone functionality will be disabled, which makes sense. Now let's run through a couple of data breach stories. GoDaddy reported that attackers gained access to 28,000 web hosting account credentials. The breach happened in October of 2019, but they only now detected the compromise. The leaked credentials were specific to accessing hosted websites via SSH. What's odd about the story is that GoDaddy said that although the attackers had SSH access, they don't see any evidence that any files were modified or deleted. They haven't provided any evidence to back up that claim, but we should note that this is from the same company who took 6 months to even detect the attack. Hackers gained access to Unacademy's database and are now selling the account information of close to 22 million users for a measly $2,000. Unacademy is one of the largest online learning platforms in India with a valuation of over $500 million. Based on the breach data, it looks like the attack happened in late January of this year. Usernames, email addresses, and SHA-256 hash passwords were leaked, and the fact that SHA-256 was used probably explains why the data is only worth $2,000. Cisco Mac has a story about the Le Figaro breach. I'm sure I breached that name. Le Figaro is the oldest national daily paper in France. The leak exposed 7.4 billion records, including personal identifiable information, or PII. The database contained API logs of subscriber data, which included full names, home addresses, email addresses, IP addresses, and passwords, both in clear text and MD5 hash formats. The article mentions that the researchers found a 8 terabyte Elasticsearch database hosted by Daddybox. I should note that every week there are always a number of open Elasticsearch servers leaks in the news. Another perhaps more devastating or life-altering breach happened this week to an adult site named Cam4, which leaked over 7 terabytes of PII belonging to its users. Once again, this was due to a production Elasticsearch instance left open to the internet. This type of leak can obviously be life-altering for anyone in it, though I suspect a number of accounts were probably puppet accounts or aliases in the database. Let's talk about how to find these servers. First, the hard way. We can use mass-scan -p9200 for port to scan the internet for every available Elasticsearch instance running on its default port. Depending on your network, I highly recommend using the rate flag to limit the number of packets sent per second. Once you've compiled your list of targets, you can then list the indexes and their sizes using just your browser by querying the target :9200 /_cat /indexes $v. Now, to search a specific index query, you can drill down by querying /the index name /_search size equals 100. And then you should probably add &pretty to make the JSON response more readable. Now, if you don't want to run your own internet-wide scan, you can use other services that already have. For example, census.io. We can query protocols :9200 /Elasticsearch. Then repeat the previous steps to see what's in the database. Now, I highly recommend using the Elasticsearch head Chrome extension to drill down. It makes it really easy to see what kind of data is stored. And for that, you'll need to open the Elasticsearch head extension in Chrome, enter the target in the search window, and click Connect. Then click on the Browser tab, and then you can click on the documents to see what's in them. Finally, the most convenient way to find open Elasticsearch instances is via Shodan. Let's see if we can find the Le Figaro and Cam4 databases that were leaked. In order to find the Le Figaro Elastic instance, you can search product :elastic port :9200 and then in quotes Figaro. When viewing the results, remember the previous clues mentioned. The organization associated with both results is Daddybox SAS, and the instances are both 8 terabyte, which matches up to the description. Now, to find the Cam4 instance, we need to read the safetydetectives.com report. It shows a screenshot, most of it is blurred out, but we can still see that the server is hosted on MojoHost, and it's a 7 terabyte instance. Let's search Shodan for product :elastic and port 9200 and org :mojohost. And bingo, we found the instance. Searching Shodan for Elasticsearch databases returns over 25,000 results. The advantage to using Shodan is that it enumerates the index names as well. Note there are other NoSQL databases that don't require authentication either. For example, there are over 78,000 MongoDB instances found, some of which have no authentication required. So to summarize, we can use tools like mass-scan, Census, or Shodan to find open NoSQL databases. We can use our browser and tools like Chrome's Elasticsearch head to access the data. Please remember that only you are responsible for what you do with this information, but hopefully this can help pen testers and bug bounty hunters to find their targets' databases that were accidentally left online. That's it for today. If you have any feedback or questions, please contact me at podcast@breachsense.io. And if you got value from this episode, then please leave a short 2-sentence review on iTunes or Stitcher and share with a friend. See y'all next week.